squirrel cage motor, and another is a slip ring motor. Okay, so now the slip ring that is for a variable speed application. Okay, so which type of motor is commonly used in industry in terms of percentage or higher percentage? So squirrel cage or slip ring? So Jivita, Ashwin, Hariharan, okay, thank you. So which type of motor is mostly used in industry means squirrel cage induction motor. Okay. So this we discussed. So based on the types of rotor, we classified the squirrel cage and slip ring, and then we discussed about the slip. So what is the slip means? This slip terms will be available only for the induction motor. So in the case of synchronous motor, the slip will be absent because both the speed will be same. Rotor speed and stator speed will be same. So slip is absent in the case of synchronous motor. So in the induction motor, what is my slip? We have some formula. Okay. So with slip is the difference in speed, difference between the speed between the stator and rotor. So it will be around 60 or 70 RPM, or based on type of induction motor, based on the design. So it will be start from 1390. So this is the induction motor speed. It will go up to 1470. So based on the construction or design, the speed of the induction motor in the nameplate detail will be in this range only, 1390, 1470. So like that it will be. So slip will have the difference in speed between the stator and the rotor. Okay. And next, what is the rotor frequency? What is the rotor frequency? What is the notation for rotor frequency? So stator frequency, what is the stator frequency? What is the value of stator frequency? தம்பி ஏதாவது interact பண்ணுங்க அப்பதான் தூக்கம் வராது. So what is the stator frequency? It is 50 hertz or 60 hertz. Stator frequency will be equal to rotor frequency, or stator frequency will be more than rotor frequency. எந்த ஆன்சருமே காணோம். எல்லாமே தூங்கிட்டீங்களா? So the stator frequency will be 50 hertz. So the rotor frequency will be in terms of 60. It will be 5 hertz, 6 hertz, 12 hertz. So it will be less than the stator frequency. So next you take the problem. Example 4. So example 3. If you are having any doubt in 3. Okay, Hariharan, ரொம்ப லேட்டா ஆன்சர் பண்ணிருக்க. Okay, very good. Stator is greater than stator frequency will be more than rotor frequency. Okay, thank you. So you take the third problem. A 6-pole alternator running at 1000 RPM supplies an 8-pole induction motor. Find the actual speed of the motor if the slip is 2.5%. So you try to solve this problem and you tell the answer. So what are the data given in the problem means? So pole is given as pole is equal to 6 pole, and n is given 1000 RPM. A 6-pole induction motor supplying running at 1000 RPM supplies an 8-pole motor. So it supplies to a 8-pole motor, and for this motor the slip is 2.5%. So these are the data given. So this is the motor running and it is supplying the input to this motor. This is 6-pole motor, this is 8-pole motor. Okay. And next you are supposed to find the actual speed. N you are supposed to calculate. So how will you calculate the n means you will go to this formula into 100. Okay. So before that you are supposed to find the frequency for this motor. So frequency is equal to Pn by 120. So from this you calculate the frequency. First step you tell the frequency. So this is the first step. Frequency is 50 hertz. Okay, Ruben, thank you. 50 hertz. The first step. Okay. Next, what you are supposed to calculate means you are supposed to calculate the actual speed of the motor. N you are supposed to calculate. And so what is the next? You calculate the NS. For this frequency, you calculate the NS 120 F by P. So here you have to substitute the new pole. What is the new pole available? This is a 8 pole. So 8 pole you are supposed to substitute here. And if you substitute mean, what is the value here? 150 RPM. Okay. So next you will come here and you find the value for N. So you know the NS value is 150, slip is 2.5%. And from this you calculate the N value. So you tell the exact N value. So N on the 731.25 correct. So here you substitute as a percentage, 2.5%. You have to convert this as a value. Okay, so you divide by 100. So that will be equal to NS minus N divided by NS. What is this NS value? 150 RPM. And you find the N value. N value will be, so you can round off this as 731 RPM or 732 RPM. So are you clear with this problem? If you are having any doubt means you can post in the chat box or you can unmute and you can ask the doubts. So if you have completed the third means you can go for the fourth problem. So next you take the fourth problem. Shall we move to the fourth problem? Complete the third one. நீங்க ஆன்சர் பண்ணலன்னா அப்ப நான் யாரை கூப்பிடுவேன், அவ்வளவுதான், வேற ஒன்றும் கிடையாது. Shall we move to the fourth problem? Okay. Thank you. Okay, you copy the fourth problem. A 50 hertz 4-pole 3-phase induction motor has a rotor current of frequency 2 hertz. Determine the slip and the speed of the motor. So you try to solve this problem. So given data is frequency is 50 hertz, number of poles is 4. So given motor is a 3-phase induction motor, and the rotor current frequency, that is the rotor frequency is given. What is the notation for rotor frequency? F dash. So F dash is 2 hertz, it is given. And determine the slip, then speed of the motor. We can calculate the slip value. Slip is 4%. Okay. So what are the given data means frequency is 50 hertz and the pole is 4 and the f dash is equal to 2 hertz. And you are supposed to calculate the slip, and the second you are supposed to calculate the speed of the motor. So how to calculate the slip? You know the formula f dash equal to s into f. So f dash is given, f is given. So slip will be equal to 4%. Okay. Second, you are supposed to calculate the n value. You are supposed to calculate n. So you find the synchronous speed first of all. So for this 4 pole, you are supposed to calculate the synchronous speed. So 120 into 50 divided by 4. So calculate the synchronous speed, then you come to the slip formula. Okay. And from this, you tell the value for slip ns 1500. Okay. And next n value. Okay, Sumant Reddy. Okay. Okay. 1439 RPM. That is equal to 1440. So in this problem, are you having any doubt? No. Okay, we'll go to the next problem. Fifth problem. A 2-pole 3-phase 50 hertz induction motor is running on no load with a slip of 4%. A 2-pole 3-phase 50 hertz induction motor is running on no load with a slip of 4%. Calculate synchronous speed and speed of the motor. You try to solve this problem. So in short term, you can write this. So n from this formula, you can write n is equal to ns into 1 minus s also. You can use this formula also from this. So you can bring this s into ns equal to ns minus n. Okay. So sns minus n, ns equal to minus ns. N. So you can write this formula n is equal to, you can take ns outside, you will have 1 minus s. So if you want to calculate the running speed means directly you can use this formula also. Instead of going for this formula, directly you can use this formula. And you tell the value. So this problem is a 2-mark problem. So you quickly tell the answer. So ns is 3000 RPM. What about n? So example 5. So ns you can directly substitute 120f by c. So you will get the value 3000 RPM. So what about n value? N you can use this formula, ns into 1 minus s. So what is the slip value given? 2880. Okay, thank you. So n equal to ns minus ns into 1 minus s. You can substitute and you can find the value. Okay. If you have completed 50 means we can go to the sixth problem. Shall we move to the sixth problem? All completed or not? Okay. Jivita, okay, thank you. So you take the next problem. A three-phase, four-pole, 50 Hz induction motor is running at 1440 RPM. Determine the slip speed and slip. So here you will use a new term, slip speed. So are you having any idea about slip speed? What is the formula for slip speed? You know the formula for slip, I know. So what about slip speed? Are you having any formula for slip speed? நடத்தும்போது ஏதாவது சொல்லியிருக்கேனா? What is the formula for slip speed? So slip speed will be the difference in speed between the stator and rotor. So you can use this formula for slip speed. So it is equal to difference in speed between stator and rotor. So this we call as a slip speed. You tell the answer, you can directly substitute and you can find the value. For all the problems, you are supposed to calculate the synchronous speed. So after calculating the synchronous speed, then only you can proceed. Okay. If the frequency is not given, you have to calculate the frequency. So you know for 4-pole means automatically it will be 1500 RPM only. So 2-pole means 3000. But you should calculate so while you are writing the examination. So what is the synchronous speed? And you tell the value for the slip speed. Answer போட்டீங்களா? இன்னும் நான் ஆன்சரே காணுமே. மீனாட்சி சுந்தரம் என்ன சார் என்னைய கூப்பிடுறீங்கன்னாரு சொல்லு ஆன்சர் சொல்லு. Slip is 4%. Okay. மீனாட்சி சுந்தரம் இல்லையாப்பா? You're not on the line. Okay. So in this sixth problem, are you having any doubt? If you're not having any doubt means we'll go to the theory part. Okay, 4%. Okay. So here we will have one new formula, that is the slip speed. So what are the formulas generally we here will use? So we'll use synchronous speed is equal to 120 F by P. So next we will use the slip formula ns minus n divided by ns. Then we'll use the rotor current frequency F dash equal to S into F. And then we'll have additional formula, slip speed is equal to ns minus n. So these are the formulas we are going to use. Okay. Slip speed is equal to 60 rpm. Okay. So are you clear with these problems? Shall we move to the theory part? Okay. So take the next topic, a rotating magnetic field. So take the topic, rotating magnetic field. So we'll call that as a RMF. So in the three-phase circuit, we are going to give the three-phase input supply to the stator winding. So what's this equation means? Suppose if you are considering voltage equation, Vm sin omega t. So Vb will be equal to Vm sin omega t minus 120. So for the third phase, Vm sin omega t minus 240 or plus 120. You can have another equation also, Vm sin omega t plus 120. You can use any equation. So this is for R phase, this is D phase, this is Y phase. So this is a voltage equation. Similarly, you can write the current equation also. So if you want to write the current equation, means Ia equal to Im sin omega t, Ib equal to Im sin omega t minus 120. Okay, Ic equal to Vm sin omega t minus 240. So as per this only we'll have the three-phase waveform will be generated. So we'll have a three-phase waveform. So will be generated like this. So like this only the three-phase waveform will be generated. It will have some magnitude. This we'll call as a magnitude. And here we'll have a time period. And this for R phase, Y phase, and D phase. And we'll have this angle as 180, 360. So each and every phase will have a time lag of 120 degree, phase displacement of 120 degree. So this is the nature of the waveform. Suppose if you draw in terms of phasor diagram. So this is a VA, VB, VC. Okay. And if the direction is like this, you can have the in opposite direction also. In opposite direction, this may be VA, this may be VB, this may be VC. And this angle will be of 120 degree. So this is the nature of a three-phase system. Okay. So three-phase system will be like this only. And here we are going to discuss about RMF. So through this RMF only, the RMF represents a rotating magnetic field. It will be expressed in terms of flux only. So it will be expressed in terms of flux only. So how the nature of the flux will be available if there is any change in the time displacement or phase displacement is there, and what will be the magnitude of the flux? It will be constant or it will be variable. So that only we are going to find, because the flux is continuously changing, or in a sinusoidal signal is continuously changing with respect to the time period. So what will happen to the magnitude of the flux? The magnitude of the flux will be vary or it will be constant. That only we are going to discuss. Okay. So with this, so we'll replace this voltage equation in terms of flux. So if you are representing in terms of phi x equal to phi m sin omega t, and phi y is equal to phi m sin omega t minus 120, and phi z phi m sin omega t minus 240. So we are writing, with reference to the voltage or current equation, we are writing the flux equation for the three phase. Okay, you can have RYB or ABC or XYZ, everything represents the R phase, Y phase, and D phase only. Again, we will replace this diagram as like this in terms of flux. So this is phi x, phi y, phi z. All are going to have the angle of displacement will be 120 degree. Okay. So up to this, are you clear? And next we are going to draw the phasor diagram, or we are going to have some angle. For different angle, we are going to calculate the magnitude. Okay. So first you take So the time displacement theta equal to 0 degree and theta equal to 0 degree. So what is the value of phi x? What is the value of phi y? What is the value of phi z? You calculate and you can substitute the value in the omega t. So theta equal to omega t, that is equal to 0 degree. So the phi m sin 0, phi m sin 0 minus 120, phi m sin 0 minus 240. And if you tell the value for this, so this will be 0 and this will be root 3 by 2 phi m and this will be plus root 3 by 2 phi m. You check, are you getting this value? Or you can write this as minus 0.866 phi m, or this can be written as 0.866 phi m. So are you clear up to this? So I will draw only for theta equal to 0 degree. You are supposed to try for 60 degree. And if you are having any doubt, means you can ask. Okay. For 0 degree means these are the magnitude you are obtained. So what are the magnitude obtained? You obtained 0 minus root 3 by 2 phi m plus root 3 by 2 phi m. Then this is the actual three-phase waveform. So for theta equal to 0 degree, we are going to redraw this diagram. Okay. So phi x is 0 means this phase will not be available. This phase will not be available. So the remaining two phases will be available. This will be 0 phi x, because here the value of the phi x is 0. So no need to draw this segment. So we will have only phi z and phi y. Okay, and this angle should be 120 degree. And next, what is the magnitude of phi y? So it is minus sign, it is plus. So plus you keep as it is, and this is a minus magnitude. You extend the line like this. Okay, in opposite direction to phi y. So this will be, you will call this as a minus phi y. Okay. So phi x is 0. So we are not having R phase. R phase is absent. So we have only Y phase and B phase. Okay. So B phase is positive value and Y phase is negative value. So negative value means you have to draw in opposite direction. So this will be minus phi y. Okay. And then you have to take the resultant. So resistance that is considered as a phi r. So this is a phi z, this is minus phi y. Okay. What's its value? Its value is 0.866. Okay. And this is here it is minus 0.86. So we are taking in the opposite direction. And this will be the resultant value. What is the phi z value? Phi z value is plus 860 phi m. So are you having any doubt in this? Means you can ask how to redraw the phasor diagram. So in the normal phasor diagram, we have all the three phases are displaced by 120 degree. And the phi x is 0, so we are not drawing this phi x. So we'll have phi y and phi z only. And phi y is in negative case, so you are drawing in the opposite direction. And what is this angle? This angle will be, here it is phi x. Suppose we are having phi x here means, and this in between this total angle will be 120 degree. Total angle will be 120 degree. This will be almost 60 degree only. So you can rewrite this equation as phi r equal to, so here we will have the two values, 3 by 2 for phi m into cos 60 by 2. So this is the magnitude value, this is the angle value. So here we are having the two phases, phi z and phi y. So both will have the similar value only. So root 3 by 2, root 3 by 2. So we have 2 root 3 by 2 phi m. And the angle is 60 degree. We are taking the resultant. So we have cos 60 by 2. And What's this value? Can you tell the value for this case? So next you are supposed to solve. What is the value for this 5R? Avinash, answer either solupa. 202.
Yes, sir.
Answer either calculator வச்சிருக்கேப்பா.
இல்லை சார், அது இல்லாமல் தான் சார் உட்காந்துருக்கேன்.
ஏன் கால்குலேட்டர் நேற்றே தான் நம்ம ப்ராப்ளம் சால்வ் ஸ்டார்ட் பண்ணோமா? நேற்றே 2 ப்ராப்ளம் 3 ப்ராப்ளம் போட்டோம். அப்படின்னா இன்னைக்கு ப்ராப்ளம் தானே கண்டினியூ ஆக போகுது. கால்குலேட்டர் எங்க ஹாஸ்டல்ல இருக்கா?
எஸ் சார்.
நீ என்ன ஆன்சர் சொல்றத நானே சொல்லிடுறேன். ஓகே, சரி சால்வ் பண்ணி சொல்லுங்க. என்ன ஆன்சர் வருது? அவர் கெட்டிங் 1.5 m வருதான்னு பார்த்து செக் பண்ணு. R is equal to 1.5 m. Are you getting? If you are having different value also, you can post in the chat box.
Sir, 2.5 வருது சார்.
2.5 எப்படி வரும்? 2.5 எப்படி வரும்? எப்படின்னு கேக்குறேன். அது வராது, 1.5 தான் வரும். செக் பண்ணு இன்னொரு டைம். Minachi Sundaram, are you getting 1.5?
Yes, sir.
Okay. So are you having any doubt on this? I will solve for 60 degree also, no problem. So remain for 120 degree, you are supposed to solve. Okay. In this, are you having any doubt? So you should get 1.5 m. So next we will go for the 60 degree. Suppose we are taking for 60 degree, and in the place of omega t, you substitute 60. Here 60. So 60 minus 120, so we get minus 60. So 60 minus 240, you will get minus 180. So tell the value for this, for the second case. And if you substitute means you will get a root 3 by 2 pi m, and this will be minus root 3 by 2 pi m, and this will be 0. So this is for the 60 degree. And you try to draw the phasor diagram. So this is for theta equal to 0 degree. So next we are going to try for theta equal to 60 degree. Okay. So here the phi z is 0. Okay. Phi z value is 0. So the phi z will not come. Okay. So what are the things you will have? Either you will have phi x. Phi x you can draw, that is equal to root 3 by 2 phi m. So phi z is absent. It will not come because it is 0. So what is the second value? So second value is phi y, and this is a phi y actually, because it is a negative value. So we will draw the phi y like this. So phi y will be equal to minus root 3 by 2 phi m. Okay, and this phi z will be 0. And next, if we take the resultant here, and this is a phi r, and this angle will be 60 degree. This angle will be 60 degree. And for this, if you are writing the resultant flux means, we'll get again 2 root 3 by 2 pi m cos 60 by 2. So you'll get 1.5 pi m. Okay. And what is the difference between these two phase diagram? Suppose if it is a 0 degree and 60 degree. At 0 degree, the resultant flux will be at this position. Suppose you consider this as a suppose this is 0 degree, this is 90 degree. It is a, so suppose you consider the example, it is at a 90 degree. It is perpendicular to this value. That is a pi x. And for this case, what will happen? The resultant flux is moving some degree for the next 60 degree. So this is the resultant flux is the magnitude. Suppose at 0 degree also we are getting 1.5 pi m. For 60 degree also we are getting 1.5 m. If we calculate for any degree, the magnitude of the flux will be 1.5 pi m only. But the angle will be continuously changing. Here it is at the 90 degree means, so the angle will be reduced. Suppose this is 30 degree means, it is moved to 60 degree for the next instant. So here it is 0 degree and this is 60 degree. So if you subtract from the 90 means we have this angle will be 90 degree. So in that we will have left out will be 30 degree. This is 30 degree and the total will be 90. And this resultant flux will have 60 degree and here it will be 30 degree. So total will have 90 degree. So at any instant, if we calculate the flux value, resultant flux if you are calculating, try to find means its value will be always constant. Suppose in this case, if you are considering this as a pi x, pi y, pi z, we are assuming. So the waveform will be sinusoidal, it will be continuously changing, but the magnitude, if we take the average value, magnitude of this waveform will be constant. So that value in terms of flux will be 1.5 pi m. So what is this? Pi m represents magnitude of the waveform. This is the angle of the waveform. So what is the position of the waveform can be found from this parameter, and this is the magnitude of the waveform. Suppose it's possible to calculate for theta equal to 30 degree. Can you try? And you tell the answer for phi x, phi y, and phi z. So if you are calculating the 30 degree means, so the resultant flux will be in between 0 degree and 30 degree, 60 degree. So you may get at 45 degree. You try to calculate for 30 degree and you post the values of phi x and phi y and phi z, then we'll move to the phasor diagram. So what is the value for phi x? Okay, 0.5 phi m. Okay, so phi m by 2 or 0.5 phi m. Okay. Second value, phi y minus 1. So that is a minus phi m. So third value, okay. Okay, thank you. Thank you. Thank you. Sanjeev Kumar, Ashwin, Arun. Okay, thank you. So this will be 0.5 phi m. And here you can now consider the three-phase phasor diagram. Okay, like this you can consider. So you know all these angles will be 120 degree. So now you are going to draw for the theta equal to 30 degree. So supposed to draw for the 0 equal to 30. Okay. And here what is the phi x value? That is a 0.5 phi m. And y values will be equal to minus phi m. And z value will be equal to 0.5 phi m. And this is the minus value, then what you will do? You will draw in the opposite direction. You will draw in the opposite direction. Okay. And this will call this as a phi y. Minus phi y, that is equal to phi m. Okay. Then you are supposed to calculate the resultant value. You will go for the resultant value. And the resultant value will be lie in the same axis. Okay. And this will be the total will be 120 degree. Okay. So resultant will be lie in this total angle. What is this total angle? 120. Remember that. And if you are writing the resultant value, what is the resultant value? So we are taking the resultant in between phi z and phi x. Phi y is already in the same axis only. Phi y is already in the. So you can write what is the phi r means phi x plus phi y plus phi z. So this is the actual resultant value. Suppose if one parameter is 0 means we will add these two parameters. And here all these three parameters are available. So already you know the value for phi y. So what is the phi y value? Already you know phi y is equal to phi m. And you are going to take the resultant only between phi x and phi z. Okay. So what are the parameters available? So that will be 2 phi m by 2 into cos 120 divided by 2. So what is the angle between phi z and phi x? It is 120 degree. So you have to take 120. So in this case, so what is the angle between these two resultant means it will be 60 degree. Okay. Suppose here we are taking the resultant in between phi y and phi z, that means the total angle will be 60 degree. So here we substituted in the resultant value as 60 degree. But in between phi z and phi x, we are having a total angle of 120 degree. So here we are, instead of 60 degree, we are mentioning as a 120. Remaining things are same only. And with this, we will add the phi y. Okay. And next you tell the answer for this case. And for phi y, we will have phi m value, and the resultant value for this two will be this value. And you tell the total value for 30 degree. So what is the answer you are getting? You solve this equation, then you will get the value. Phi y will be equal to, what is the value for phi y? So phi y is equal to phi m, you can directly substitute. So what is the value for cos 60? Is 2 cancel பண்ணிடு. 2 cancel பண்ணிடு. What is the value for 120 na cos 60? What is the value for cos 60? 0.5. So 0.5. So 0.5 phi m plus phi m. Okay. So what is the total value? 1.5 phi m. Okay. Hariharan. Okay. Good. So if we refer these three waveforms, so you can identify the rotation. So in the first case, theta equal to 0 degree. So the resultant flux is at this position. This is a resultant flux. And theta equal to 30 degree. So this is 30 degree. So the resultant flux will be at this position. And what is the third case? Theta equal to 60 degree. So the resultant flux will be at this position. So like this, the resultant flux will be moving in the circular shape. We calculate for up to 360 degree. We calculate means we will get a circular shape and the angle will be varied. The angle will be varied for a different time period. Here, so theta here, the time is here. The theta is going to be varied from 30 to 360 degree if we consider for one cycle. And if the time is continuously varying, so the position of the resultant flux is going to be varied, but the magnitude will be remains same. So this magnitude we call this as a 1.5 phi m. So are you clear with this RMF? So if it is asked means you have to explain with the help of phasor diagram. So from the three-phase voltage equation, you have to form the flux equation. Okay. So phi m sin omega t, phi m sin omega t minus 120 or plus 120 or minus 240. So like that you can consider. And for different values of theta, you are supposed to solve. And then finally you have to conclude like this. For calculating for the different angles, so the angle is continuously changing, but the magnitude of the rotating magnetic field RMF remains constant. Okay. The phi m we can have any value. Suppose example, so we will have a general equation. So phi x equal to phi m. So this value may be anything. This is a magnitude. You may have 220 volt, you may have 440 volt, or you may have 415 volt. This is in terms of voltage value. And similarly, we can have a flux. In terms of flux also, we can have the magnitude value. Okay, this is with respect to voltage or current we can have. And based on this magnitude only, we'll have the angle is going to be changed. Okay, this magnitude will be remains constant. And the flux is going to be with respect to the angle, the position of the magnitude is going to be changed. So that's all about the RMF. Are you having any doubt? So in this, with respect to the RMF, other doubt rika? So finally, you have to write the one expression. If the angle changes also, the resultant flux will remains constant. So that is the conclusion of this topic. Okay. This rotating magnetic field will be available in stator or rotor, or both will have. Rotating magnetic field will be produced in the stator part or rotor part. Rotor. Okay. So here the flux represents it is not an actual rotation. Flux is an imaginary line. So this flux, rotating magnetic flux will be generated on the stator only. So due to that only we'll have a movement, physical movement on the rotor part. So this rotating magnetic field is applicable on the stator part. Okay. So this is the magnetical rotation. Flux is a magnetical rotation. So with this help of this magnetical rotation, we'll have a mechanical rotation on the rotor circuit. Okay. So next we'll move to the next. Next you come to the slide. We'll discuss in the. So regarding the construction, we'll have this general point. Slide okay. So these general points will be similar to DC machine and AC machine. So frame na will have a outer cover. So what is the material we are using? It will be cast iron. So these are the common points with respect to the DC machine and AC machine. So stator and rotor core will be made up of silicon steel lamination. Okay. And the stator and rotor winding. So we'll have a copper windings. So over the copper, so we'll have a varnish coating will be available over the conductor, copper conductor, and it will be moist proof. Okay. So what is it? It will absorb the moisture available in the atmosphere. Okay, or in the air. The next we'll have a air gap between stator and rotor. And then we'll have a shaft and the bearings will be available. That will be ball and roller bearing. This point we missed in the previous class, so that only I am giving as additional. And then we'll have a fans will be available in order to cool the winding when the particular machine is operating under overload. So this fan will be attached to the shaft. We have a light aluminum fans will be available. So we discussed about the slip rings and enclosures. So what is the material we are using for the slip rings means we will have phosphor bronze. Okay. So these are the additional points related to the construction. So next we will discuss about the equivalent circuit. One second. So next we will discuss about the equivalent circuit of induction motor. So we'll have some idea. Okay. So already we discussed that. So the transformers and the induction motors will be same. Okay. So, see the first diagram. Okay. So what is the difference between the transformer and induction motor means? So already I told you that induction motor is a, what is the other name for induction motor means rotating transformer or polyphase motor. Polyphase, three-phase we'll call that as a polyphase motor. So what are the elements available in the circuit means we'll have a stator resistance, stator reactance, rotor resistance, rotor reactance, and then we'll have a mechanical load. So if you see the first diagram, so what is the additional parameters available in this circuit diagram compared to transformer? If you refer the transformer equivalent circuit, what is the additional element available in the equivalent circuit? You can see and you can post in the chat box. So we'll have an input voltage V and we'll have a supply current. We'll have a rotor resistance, reactance. Then we will have a core loss component, no load current I naught, RC represents core loss component, XM represents magnetizing loss component. Then you will have a EMF on the E1 is the EMF on stator or rotor, stator or primary winding. Then in the secondary side, so we'll what is the difference between the transformer and the induction machine? You can refer the first equivalent circuit and you can tell the answer. You post the answer in the chat box. What is the additional element we are included in the case of induction motor? Any additional elements we are included or not? If included, what element we included? என்ன டிஃபரன்ஸ்னே தெரியல. டிரான்ஸ்ஃபார்மர் அப்ப வரவே இல்லையா ஈக்குவலன்ட் சர்க்யூட். You can refer your notes and you can refer your notes and you can see this equivalent circuit. And here we will have only one element in addition with respect to induction machine. So remaining elements are similar to transformer one. So transformer primary is considered as a stator here. Transformer secondary is considered as a rotor. But in transformer we are not having any rotating part. Here we are having rotation. So we will include one parameter. What is the parameter we included? Variable stator. No. You see the element. What is the element? R, X, Z, R01, X01, Z01, I1, I2, I0, I2 dash, K. So like that we'll have many parameters. In that a new parameter we included in the equivalent circuit. You see the first circuit carefully and you can tell the answer. You see the PPT carefully, then you can tell the answer. JX2. J full போட்டியே ஒன்னு விட்டுட்டியே. JX2 ன்னு இல்லவே இல்லையே. JX2 ஆ அதான் X2 ன்னு இருக்கு டிரான்ஸ்ஃபார்மர்ல. JX2. Okay. S தான் we are including the slip. Slip is the additional parameter here we included because we are having rotation in the case of induction machine, induction motor. Statorல இந்த S என்ற வேல்யூவே இருக்காது டிரான்ஸ்ஃபார்மர்ல பாத்தீங்கன்னா. டிரான்ஸ்ஃபார்மர்ல S ன்னு ஒரு டேர்மை இன்க்ளூட் பண்ணிக்க மாட்டோம். ரிமைனிங் எல்லா பேராமீட்டரும் சேம் தான் டிரான்ஸ்ஃபார்மருக்கும் induction motor. If you compare both transformer and induction motor, the remaining all the parameters are same except slip. Slip, if you are having a mechanical load or a mechanical rotation or you are having a mechanical load, automatically this slip will come into the equivalent circuit. Okay. So in equivalent circuit we will have the slip value. Okay. So in the output side, so if you refer that we will call that as a mechanical load. So here if we consider this parameter alone, this is the parameter available on the output side. So this will be the difference. And here we are going to just consider as I2 dash example. So R2, this we are calling as a X2. And in the input side we have SE2. Okay. So this slip is addition with respect to the induction machine. Okay. And with this, if you are writing the I2 dash equation means SE2 divided by root of R2 plus SX2. Okay. So you divide this entire equation by S. So I2 dash equal to E2 divided by root of R2 by S whole squared plus X2 squared. Okay. And then you can redraw the circuit like this. You can have a fixed inductor and a variable resistor. So what is a fixed inductor? X2 and the variable resistance. And this input will be E2. You can draw the equivalent circuit like this. And then again, only this term we can write like this. So R2 by S, we can write as R2 plus R2 by S minus R2. And if you are writing like this means we can rewrite this again. You can take R2 outside. So we have 1 by S. And again you can redraw this circuit as a third diagram. You can have a fixed R2 and you can have a fixed inductor and we will have a variable load. This is R2, this is X2 and this is a variable load. You can represent as R2 into 1 minus 1 by S. Okay. Or if your font rate means like this, also you can write 1 by s minus 1. 1 by s minus 1. So, in order to have a fixed resistor and fixed inductor and a variable load, so we are rearranging the equivalent circuit like this. So, this is the initial equivalent circuit. So, this part is called as a mechanical load. This SX2 is called as a mechanical load. And we are replacing say fixed inductor and a variable resistor with respect to slip. So, again, in order to have a fixed resistance, we are adding a resistance and subtracting the resistance. And you are rearranging the equation like this. We have a fixed resistance, fixed inductor, that is on rotor side, and we will have a variable load. Okay. So this is the small conversion to have a simplified equivalent circuit, so that if you are referring to the stator and rotor, it will be easy. Okay. And so if you are you know the some of the parameters. Okay. So I will go to the parameter. You know this stator terminal voltage, stator current, stator resistance, leakage reactance, impedance, and then input current, core loss component, everything you know. And this is the expression we did. Okay. So I2R, that is represented as I2 dash or I2R. I2R represents the rotor. So, so this is simplifications we have done already. And you know this parameter, what is the K? So K we'll call as a transformation ratio. So yeah, E2 by E1 equal to N2 by N1 equal to V2 by V1 equal to I1 by I2. You know all these things. And if you want to refer the parameters from the primary to secondary or secondary to primary, so we'll have some conversion ratio with respect to the transformer. Okay. You know what is by X2 dash means we are referring to the primary. So X1 dash means we are referring to the secondary. So what are the parameters available on the input side means we'll have R1, X1. In the secondary side, we'll have, that is the stator side, we'll have R2, X2, and then we'll have a mechanical load. Okay. And if you are referring to the primary, so you have to follow similar to the transformer only. What similar to the transformer, if you are referring any parameters from the secondary to the primary means, and you have to divide by K squared. So that is a X2 dash represent divided by the K squared, and if it is a voltage parameter, we will divide by K. Okay. So this is the case. And these equations, you know, what is by R1E or R01. So R01 represents, we are referring the secondary parameter to the primary. Okay, we will have R1 as a fixed, then R2 divided by K squared. You know, X01 or X1B is represented as a X1 plus the secondary reactance referred to the primary. And with respect to this, and what is the role of this I naught? From I naught, what type of losses can be calculated? So what is the need of this equivalent circuit? Are you having any idea why we are having this equivalent circuit? What parameter finally we are supposed to calculate from this equivalent circuit? So what is the need to have a step-by-step procedure to obtain the equivalent circuit of a transformer or induction machine? So we'll have two different circuit. Okay. Secondary we'll have a separate circuit. Primary we are having a separate circuit. So we are making the two circuit as a single circuit. That is the role of a equivalent circuit of the system. And if it is a single circuit, it is easy to find the parameters of the circuit. It may be any parameter. It may be a reactance or resistance or impedance or voltage or current. Everything it will be easy. And if you are having a simple circuit like this means, it is easy to find the parameters of the machine or transformer. And if you know the parameter means, it is easy to find the losses and efficiency and output. Everything will be easier. So that only we are going for this equivalent circuit arrangement. Okay. Next, what is the role of this part? Are you having any idea? What is the role of this circuit? From this, what you can find? So by this circuit alone, why? What is the need of this circuit, or what is the name of this circuit? From this circuit, what are the parameters you can calculate? So why it is mentioned as no I naught no load? What are the parameters you can calculate in the no load? What type of loss you can calculate? Find losses, okay. What type of losses? We'll have different losses, no. What are the losses? We'll have a core loss, copper loss, friction and windage losses, copper loss and iron loss, copper loss. Okay. So you already done some experiment on transformer. You are not done, I think. Okay. From the no load test, what type of losses can be calculated? It is a no load. I naught represents no load. If you not means everything is no load. From no load test, what type of loss can be identified? No load means current will be minimum. So what type of losses can be obtained? You can calculate iron loss. Iron loss மட்டும் தான் calculate பண்ண முடியும். Okay. This element are used to identify these parameters you can calculate from the no load test. So generally we'll have in transformer we'll have a open circuit or short circuit test. Same test if you are conducting on the induction motor means we'll call that as a no load test and blocked rotor test. We'll call that as a. So in the transformer we'll have that test name. So we'll have the same procedure. We'll have the same equivalent circuit, everything. So if it is a transformer, we'll call as a OC test. This is a SC test. So in the induction motor, so we'll call this as a no load test. And here we'll call this as a block the rotor test. Okay. So these are the difference between the transformer and the induction machine. In the transformer, if we conduct OC test means we can calculate iron loss or fixed loss or core loss. And in this short circuit test, sir.
And the quiz question ready பண்ணிங்க சார் போடலாம்.
சரி சார் இத முடிச்சிட்டு போடலாம்.
சரி.
So in the from the short circuit test you can calculate I squared R loss, copper loss or variable loss. Okay. This all are similar to, we have different names. So this same parameter we can calculate here also. In no load test, we can calculate the fixed loss. From the block rotor test, we can calculate the copper loss. The parameters related to the copper loss. So up to this, we'll stop. We will continue with the next class. Same equivalent circuit will continue. We'll have some more equation with respect to the equivalent circuit. We'll discuss in the tomorrow morning class. Okay. Sir, Nagaraj sir.
சார்
போட்டுருங்க சார்.
ஓகே சார்.
So now you attend the, you go to that link and you attend the answers. Okay. So multiple choice questions related to induction motor, I think.